was in first year of mechatronics. I'm going to deal with the topic variometer. To start with, let's see some basics of projectile motion. And projectile motion, as you know, has got a horizontal velocity as well as a vertical velocity. And resultant of this one results in a curved path for the projectile. And through variometer, what we aim at is measuring the vertical velocity of the projectile. And usually flight motion can be considered as a projectile motion, as it is a motion through air, and anything that moves through in a gravitational field can be considered as a projectile. And during the motion, there can be a pressure variation within the navigator as well as pilot. This can be blinding the sensors of both of them, and this can result in danger while flying in such kind of scenario. And this kind of scenario can occur during turning, swinging, and soaring of the aircraft. And while these scenarios, there need to be an external aid for the navigation or navigation assistance, and variometer serves this purpose. Variometer is also known as rate of climb and or rate of descent indicator, as it shows both the rate of climb, rate of going upward velocity as well as rate of downward velocity, and also known as vertical speed indicator or vertical velocity indicator, that's VVI. And in short, we are usually denoting variometer as vario. And here we can see a diagram of a variometer where it shows the vertical upward velocity as well as downward velocity, and it is measured in feet per second in this particular instrument. As I said before, variometer senses the rate of change of altitude by detecting the atmospheric pressure that changes with altitude. And as everyone knows, the pressure can be determined by using the equation E is equal to H into rho into G, where H is the height from the ground and rho is the density of the air, and G is the acceleration due to gravity. And with increasing height, there can be a decrease in density of the air, and this can result in low pressure at higher altitudes. And the rate of decrease of this pressure can measure the vertical velocity, and while going up and while coming down, rate of increase of this particular pressure can measure the downward velocity. And as I said before, the pressure change in pressure is proportional to change in height, or it is also vertical velocity. Here we can see the schematic diagram of the same, and this one is a purely mechanical type of variometer, and here we can see a diaphragm which is connected. The whole is connected by a calibrated lead, and the air from the outside atmosphere enters into this chamber through the calibrated lead, and with respect to the pressure of the diaphragm expands and contracts, and this diaphragm expansion and contraction of diaphragm is calibrated in such a way that it responds to the rate of change of the pressure outside, and that is connected to a particular indicator of it, which is known as a needle pointer. That was, as I showed on the previous diagram. Here we can see this is an indicator set up for the variometer. Well, while I mentioned variometer, everyone can have the doubt of what is the difference between variometer and altimeter. Altimeter is a device which senses the pressure and which in turn detects the corresponding height from the ground or altitude from the ground, while variometer detects the rate of change of this altitude. And as I said before, the basic function is same, but while calibration we are the rate of change of pressure is proportional to the rate of change of height, and this principle is used in variometer, while in altimeter the proportionality of pressure and height is used. let's see with the sensitivity of the variometer. Variometer used in modern seaplanes are of extreme sensitivity because they need to sense even slightest variation in the vertical velocity, and expected sensitivity can be as big as those because of the convection. You can see while holding a brass tube of have 1/8 inch side and 1/8 inch length, there can be a convection flow of air as shown here, which start from the upper end and which on cooling will come down and the cycle repeats. And this flow air can be of almost 0.02 cubic centimeter per second or equivalent, and one cannot expect this kind of velocity to be so high so that it can be detected by a normal airflow sensor, and the sensitivity of variometer is required to be held to be very large. And as I said earlier, to change the variation in the pressure with the altitude is much smaller or minimal, and hence the thermal the rate of change of this atmospheric pressure also is simultaneously low, and hence the sensitivity is required to be very large. Well, a simple variometer is constructed, as I said before, by adding a large reservoir to augment the storage capacity of a common aircraft range of flying instrument. And as I shown before, it consists of a container which consists of a diaphragm which expand and contract with respect to the atmospheric pressure. When the aircraft altitude, the pressure outside the aircraft changes and air flows into the bottle or container, and if it is going down, the air flows outside the container. Let's concentrate on total energy compensation in variometers. Well, there can be a scenario where aircraft is moving through a thermal. Thermal means area within the atmosphere where the temperature is rather non-uniform because of the different atmospheric conditions like presence of clouds or moisture, and it is required to compensate the total energy as well as to avoid the error or external interference in the reading obtained in the variometer. And here is the theory behind the total energy compensation. Well, as everyone knows, potential energy plus kinetic energy forms the total energy of the system. The compensation of cancel the stick thermal is, well, while moving upward, the potential energy is gained, and while moving to the upward position, the kinetic energy is converted into potential energy, and this is almost equal for conservation of energy. And here we can see that rate of change of these energies are equal and in the opposite sign, because the energy once potential energy is gained and kinetic energy is lost, and it is on the equation. But as everyone know, the potential energy E4 can be written as mgs. The M is mass of system, G is the accelerated gravity, H is I. So we can say E4 or E potential is proportional to I of the system from the ground. While kinetic energy, as everyone know, is E kinetic energy is equal to half mv square, and hence it is proportional to v square. If the mass is constant, it is proportional to v square, and it is shown in the equation 2. Hence we can say the rate of change of height is proportional to minus delta v square. That is because as potential energy is gained, kinetic energy is lost, and hence the negative sign comes out there. And delta H is a height compensation required while taking an uncompensated reading, and there are several mechanisms for compensating the reading obtained from the uncompensated variometer. Let's see the practical application of the compensation. These are the well, can be achieved by total energy probe device. Well, this is a device which produces a vacuum which is proportional to the square of the velocity, and this produces a negative pivot which can be subtracted from the actual mechanical measured pressure, so that we can compensate for the high for the delta H obtained in the for the rate of delta H which is obtained due to thermal or thermal motion. And as this system is so complex and very much expensive, very much few aircraft use this technology basically. And total energy prop, as I said before, is a classical Venturi tube which consists of two funnel connected back to back. Here, while moving inside, there is a pressure variation which compensates for the variation in the thermal motion and the pressure. The more recent advancement in the field of research have brought a tubing tube or a slot or pair of balls on the back side of the quadrant vertical tube. Geometry of the total energy probe is of air that generates suction or reduced pressure inside the system. Well, this is in turn, this is what I mentioned as the vacuum which compensates for the thermal motion. The total energy probe needs to be undisturbed airflow ahead of the aircraft nose or tailwheel. These are the precautions required for the thermal for the placement of total energy probe. Well, there is a tube, certain tube named as Braunschweig tube, which is a long cantilever tube with the key and in the end, seen projecting from the leading edge of the tail fin on most of the sail planes. This for the maximum precision of the compensator. Next, another type of the compensation measure is netto variometer. This is a type of compensation measure which is indeed a type of variometer, and well, it adjusts the intrinsic speed rate of the glider at a given speed, adjusted for the wing loading due to the water ballast. Well, while placing a netto variometer in a still air, which always shows a zero reading, this provides accurate measurement for the pilot for taking the reading. Well, relative nettometer is another type of nettometer which indicates the vertical speed the glider would achieve, and it is actually a sort of prediction measure. And if it flies at the which is used while the glider is flying at the thermal speed, independent of the current airspeed and altitude, we can measure the vertical velocity using relative netto variometer. When the glider circles through the thermal, the pilot needs to know the glider's vertical speed instead of that of the air mass. While the glider is moving towards the certain kind of thermal, it is quite well. The point which decide to for the pilot needs to know the glider's vertical velocity, and while using the netto variometer, we can know the correct vertical speed used in the particular thermal. But the relative nettometer sometimes include a G sensor to detect the thermally. When thermally the sensor will detect the acceleration due to acceleration plus centrifugal. While centrifugal is the centrifugal force experienced by the aircraft while moving in a turn, and the relative netto variometer with subtracting the sailplane in load adjusted to polar swing rate for the duration. Some earlier netto is used manual switch instead of key sensor. Well, it was operated manually by the pilot during some airline models, and nowadays it is converted to an automatic model with the help of a key sensor. Now let's see different types of variometers. It can be a purely mechanical system, or it can be a combination of mechanical as well as electrical systems. But let's see what are the main types of purely mechanical system variometers. They are leaky capsule vein type and pellet type variometer. And coming to the combination of electrical and mechanical system, this can be a combination of electrical systems like container or diaphragm and a system for sensing the change in pressure such as thermistor type or ball electric type. Leaky capsule type variometer is one shown in this diagram, which was previously shown in the schematic diagram, where there is an outside air source from which static air source from which the air enters into the system, and with change in the pressure there can be a deflection or expansion or contraction in the diaphragm or pressure sensing capsule, which is connected to the leak or calibrated leak, which is calibrated to a particular sense the particular change in the outside pressure, and with respect to the change in the outside pressure, the diaphragm expands and contracts, which results in a particular value of the upside or downward motion of the pointer. Then, as I said before, the operates by measuring the pressure drop across the fixed resistance where restriction R, as I shown in the diagram. Fixed restriction is shown here. Between these 2 points, there will be a pressure drop, and the diaphragm expands and contracts with respect to the pressure difference. And the static force is C plane. There can be static force is a form of 40 inlet for the atmospheric air to enter the system. Whereas the pressure drop across the R or restriction is proportional to the rate of flying or descent measured by the sensing capsule. As I said before, the diaphragm or the pressure sensing capsule expand or contract with respect to the change in pressure, and which in turn is calibrated to measure the rate of change of the outside pressure, and this shows the vertical velocity of the plane or the system. Next is the vein type variometer. Vein type variometer, the pressure drop across the restriction between the vein and case is a measure of rate of climb. You can see in the diagram. There is a vein which rotates, and vein and casing, there is a casing, and there is a pressure difference between outside static source and reference chamber. There will be a deflection in the vein, which in turn causes a deflection in the pointer, and at the equilibrium position, the equilibrium position of the system is where the vein, where the torque in the head spring balances the forces of the vein, or because of the weight of the vein, there can be a motion of the pointer, which is balanced by the torsion of the spring, and while it is moving upward, air passes from the capacity to the restriction. As you can see in the diagram, while moving upward, the air passes from the capacity, the storage medium to the outside, and this results in the movement, and which indicates that the diaphragm to move. So not diaphragm, the pointer to move upward, and vice versa happens while going downward. The pressure of the outside air increases while going down, and with increasing the pressure, there can be an inlet of air, which will result in the downward motion of the vein as well as the pointer. Next, you can see pellet type of variometer. We can have 2 small pellets in cross-connected tapered tubes. As seen here, there can be 2 tubes, or there can be 2 pellets. The motion of these 2 pellets can be varied with respect to the static source, and the proportional movement of these 2 pellets can denote the vertical velocity, also known as variable area air flow meter, and it operates on the principle of fixed pressure drop across restriction that varies in an area. The area air flowing out of the reference chamber C, as seen here, reference chamber C will rise the green cord, and the air will exhausted through the static cord of the same plane. once lowered, while the system is going down, the green cord will go and you get back, and the balancing out on the tapered tube forcing the air to go through the other branch, lifting the red cord, and while going down, as I said before, the green cord goes down and the red cord comes up, and the air flowing out of the reference chamber will raise the green cord, and the air will be exhausted through the static cord of the same plane while the system is going upward, and once lowered, or while the system is going down, the green cord will drop and back to sea, forcing the air to go through the other branch, lifting the red cord, allowing the air into the sea. As I said before, while going down, the pressure drop, or pressure increases, the atmospheric pressure with respect to the chamber increases, and because of that there is an inlet of air, and this results in the upward motion of the red ball, and will result in the downward motion of the green ball, because it is directly connected to the static source, and while there is an inlet, the air from the outside can push this green ball downward, while the red ball will be pushed upward. So we can sense the direction of the motion by seeing which ball is going down or which ball is going up, and while going down, as I said before, the green ball comes up. While coming up, while going down, the red ball comes up. While coming up, the green ball comes up, and the red one comes down. Then next is the electric type, or combination of electric and mechanical type of thermistor, and first type is thermistor type of variometer. The rate and direction of the flowing air measured by cooling of one of the two cell-heating thermistor, where there is a production of the heat, and differential cooling of these two thermistors, and the subsequent voltage is used for sensing the vertical velocity. This is a schematic for thermistor type of variometer. As you can see, these two dots here, these are two thermistors which are of even smaller than a pinhead, and there can be two separate voltage dividers. This output is taken to the differential amplifier also for an op-amp, where we can have different, while there is an inward flow, or while the aircraft is going down, there can be an inward flow of air from the static source to the chamber, and this can result in differential cooling. First this one will be cooling, and after that this one will be cooling. Or while going upward, there can be an upward flow of the air, so that this first thermistor will be cooling and second one will be cooling slowly, because there can be these are self-heating, so that there may be an internal heat produced in these thermistors, and differential cooling of these two is sensed for sensing the velocity. Well, as I said before, the inward or outward motion of the air can result in the differential cooling of the thermistor, and this result in a differential load will be sensed. Let's see the polar electric type of variometer. This is a diagram of a polar electric type variometer. We can see a static cord, and our system is pressurized to a particular calibrated pressure, and there can be an inlet or exhaust of the air from the system with respect to the outside pressure, and the motion of the diaphragm is sensed by two variable inductors. You can see here, one is an inner inductor and the outer inductor, and the difference between the voltage or output of these two is sensed for sensing the velocity of the system. And there can be several other adjustments for the system, such as high gain, which are required for calibration purpose, and here we can see a compensation measure of total energy capture, as I said before. The high compensation is maintained with help of a vacuum, which is generated by a mercury tube, and this can be seen here. Compensation of the heat is high is achieved. As I said before, the the ball electric type variometer senses the background reflection by using the variable detectors on the figure. As I said before, the inner detector as well as outer detector, and this kind of ball electric type of variometer, since they are employing detector type of sensor, they can be very sensitive as well as rapidly responding, since the response of the detectors can be so high. Well, this is a schematic arrangement for a electric type of variometer. As I shown before, the electric type of variometers employs differential voltage system. Two difference between two points are considered while in inductor type also, and as well as in thermistor type, there can be seen two sensors of the same type, either thermistor or inductor are used, and then we can see a differential amplifier setup extended. Here we can see two transistors connecting back to back, where there can be an input from a thermistor, either a thermistor or a inductor, as I said before, and the difference between these two voltages is amplified and is fed to a system where there is a signal conditioning unit, and after that we can get the output in a display or in indicator. Well, as I said before, the G1 and G2 can be either a thermistor, or here we are denoting two thermistors. They are V1, V2, 4, 5, and those four are thermistors in this circuit, and there is a different amplifier setup using two transistors of the same type, and there are 2N, 270, and there can be a set of calibration resistors, and the balance between these two input resistors are mainly using a board for that. As you can see out there, there is a balance resistor. The two thermistors are, as I mentioned before, are T1 and T2. Well, virtual schematic, as I said before, is that different amplifier setup used to drive the meter and to tailor the circuits of the characteristics of the circuit. This is the advancement of the field of variometers and their applications. Recently, there have been several types of advanced variometers where there can be electronic display, and there present several other kinds of information other than the vertical velocity. They can be either position, geographical position such as altitude and longitude, and also they can be usually come in a combination of with the variometer, and the display can thus show the bearing distance and height required to reach an objective. Well, this variometer has played an important role in the development of this sport of paragliding, as well as the club playing competition, where the competition between different clubs, aircraft clubs are being done, and the display can thus show bearing and distance, height required to reach an objective. While in cruise mode, the variometer can also give an audible indication. As we have seen in several movies, there can be a variometer attached to the wrist of a paragliding person, and this one will give the accurate indication of the velocity with which he is going down, and this is usually denoted by an audible sound, which can be through sound whose frequency increases with respect to the velocity, and the speed of sinking or soaring can be easily measured by this kind of instrument. As I said before, the audible indication can give the correct speed depending on whether the air is rising or sinking. The recent trend for advanced variometers is to interface the system with the computers, flight computers, which assist the pilot or navigator in navigating the aircraft or glider or whatever the flying equipment. It can present information such as control airspace, list of turn points, and even collision markings. Well, while moving to a particular collision or obstacle, if the radar or the navigation system of the aircraft senses particular kind of obstruction, there can be a prediction to how much time we can have how much time is there before the impact with respect to the current velocity or vertical velocity. And usually while going through any of the crash plans and other scenarios, worst case scenarios, there can be an application of the variometer where we can see how much speed the aircraft can reach the ground with that particular prediction mechanism, and that we can be easily prepared for the impact. And yeah, there can present information such as number of aspects, list of turn points, and even collision warnings. Well, some will store, as I said before, can store positional GPS data during the flight for later analysis. As I said before, it can store the latitude and longitude of the longitudinal data of the system. Well, we can use for future reference. As I said before, there can be a variometer which generates an audio output speech, and return depends on the instrument reading. And this can be an audio tone of particular frequency or which is of audio frequency. And audio tone increases in frequency as the variometer shows a higher rate of climb, and decreases in the frequency towards a deep drone as the variometer shows a faster rate of descent. While moving upward, this case scenario with the particular kind of aircraft, while using in paragliding or scenario by parajumping, there can be the vertical velocity can be denoted in such a way that while going down, there can be a increase in vertical velocity, and with respect to increase in vertical velocity, the vibration or the pitch of the output can be increased. And here we have mentioned about the aircraft, and the aircraft is showing a variometer showing a climb or aircraft is going up. The tone is chopped, and the rate of chopping may be increased. As rate of chopping means the duration between the sound pulses can be increased as the climb rate increases. While during a descent, the tone is not chopped, and while the variometer is in still air, or while the variometer is in ground, you can have it does not produce a sound. And as I said before, while it is in the ground, the drop or change in the pressure is very minimal, and this cannot be sensed by the system. The audio signal allows the pilot to concentrate on the external view rather than concentrating on the instrument panel. And as I said before, in the scenario of crash landing, there can be a scenario where the pilot requires to have a view of the external environment so that he can have a safer place for landing. And during such scenario, the audio signal helps the pilot as well as simultaneously gives an input, gives an indication of how far we can just release the ground. And variometer that produces audio tone is also known as audio variometer. Here we can see a more advanced type of digital variometer which is used in flying balloons. This particular kind of variometer is generated by, was manufactured by Flytech system from Switzerland, and there can be two ribbon type indicators which shows the vertical velocity as a progress bar, and this particular system employs several other type of secure with the pilot. He can control the aircraft path, and the variometer attached to this aircraft can variometer attached to the remote aircraft can give a indication of the current vertical velocity if the aircraft is not outside of the navigator, and this kind of instrument is usually prohibited in radio soaring competitions where there is a professional competition between the pilots, and yeah, the variometer used in radio control soaring may or may not feature coordination compensation. As I said before, these are complex systems, and the compensation systems may add up to the further weight in the system, which, as everyone knows, the aircraft which is used for remotely controlled are rather small size, and adding an extra system to the same can result in extra weight, and hence they are usually not included. Well, the popular brands of radio control variometers are bipolar area and pitch large carrying system. This I can